Hello students, this is the corrected solution to example 3 earlier made, and let's have this additional hint. So water flows down a wide channel of concrete. N is 0.014 laid on a slope of 0.002. So let's stick to the original slope. Find the depth and the rate of flow for critical conditions in this channel. So we have this hint. B is 100 meters. Earlier, we could only consider 1 meter wide channel. So therefore, it is not wide because it is only 1 meter. So this should be the correction. So we will let B be 100 meters. So critical velocity, which is square root of G critical depth, is also 1 over N hydraulic radius critical to the 2/3 slope to the 1/2. So substituting where hydraulic radius critical is area 100 times critical depth over 100 plus 2 times critical depth after we let the width of the wide channel to be 100. So 9 square root of 9.81 d sub c is 1 over n hydraulic radius critical to the 2/3 slope to the 1/2. Using your calculator, d sub c is 0.9587 meters. So the critical flow rate is depth critical times critical velocity. So 0.9587 times square root of 9.81 times 0.9587. So the critical flow is equal to 2.940 cubic meters per second per meter. Likewise, for part B, when the channel is very wide, so that means you can assume 500 meters or more, or greater than 500 meters because it is very wide. And we note that the ratio of B to B plus 2 d sub c, because d sub c is not that high, would be approximately equal to 1. This ratio B over B plus 2 plus 2 d sub c is almost 1. So that's why we can let that equal to 1 so that the hydraulic radius critical is equal to the critical depth. So to demonstrate that, let us assume that B is 500 meters. Remember, it's very wide, so you can assume 500 or more. And 500 divided by 500 plus 2, assuming critical depth is 1. So that's 500 over 500. So that's why it is close to 1. We can replace this B over B plus 2d sub c by 1. And therefore, hydraulic radius critical is equal to the critical depth. So using this same equation here, we will just replace hydraulic radius critical to critical depth. Then the result is solving for critical depth, square root of 9.81 times 0.014, then divided by square root of 0.002, then the answer raised to 6 because the net exponent of d sub c after we cancel the exponent is d sub c to the 1/6. So raised to 6, d sub c is 0.8886 meters. So the critical depth is 0.8886 meters, which is close to this. Much more if we let B be 200, they will be very close. So the critical discharge therefore is 0.8886 times square root of 9.81 times 0.8886. So the critical flow is equal to 2.624 cubic meters per second per meter. So again, these answers will be close if you make B to be higher than 100 meters. But for this problem, for a wide channel, this is enough. If it is very, very wide, then you just replace b over b plus 2d sub c by 1. And we can also assume here that b is maybe 1000 or 500, and definitely this critical depth will be almost the same. So that's it for this video.